Hello, this is Nia. I'm an MLIS student at the UBC iSchool. So I'm going to look at information retrieval in the context of environmental science with a specific focus on students who are entering the field. I review concepts from computer science and library studies related to the ways that systems and users work together to construct queries. I also review studies about information needs of environmental scientists just to help build a disciplinary context. I'm recording this presentation from the traditional territories of the Lakhtamish, the Lummi people, where I live as an uninvited guest. I'm also a neighbor to the Nooksack people, whose traditional territory surrounds me to the east, toward the mountains. So I want to acknowledge that my interest in academic librarianship is rooted in a desire to support teaching, learning, and research that draw on multiple ways of knowing. And this has been informed by the leadership of Lummi and Nooksack people on science relating to climate change. The photo on the left here is one that I took of research by the Nooksack tribe on glacial melt. They're doing a long-term study of in-stream flow and salmon habitat involving measuring the impacts of climate change on the melting of the glaciers. And on the right is a photo I took at the Lummi Nation's annual Stomach Water Festival, which normally takes place in June. Environmental science is an interdisciplinary field. It touches on a lot of different disciplines, even beyond the ones listed here. Within environmental science, some important information needs include finding information that's specific to a location, being able to search gray literature, so government reports, environmental impact statements, as well as open data sets, which, given the interdisciplinary nature of the field, can be challenging to find in the normal disciplinary places. Environmental scientists approach querying mostly relying on keyword searching and complete phrases, as well as a smaller number of people who use Boolean operators. A frequent query approach would be to use the name of a topic, like flooding, plus the name of a location that you're interested in. And this is challenging with what we know about information retrieval, because the name of a location could be at any level of jurisdiction, as well as it could be the name of a geographic feature or a culturally specific name, and all of these can overlap in all sorts of ways. So when somebody writes a query with the name of a location, they might miss a lot of results that are relevant to them, unless the search system is able to accommodate all of that complexity. So looking at specifically at undergraduate students, what I found is pretty similar to web users in general. When it comes to database searching, there is a preference still for natural language search and this belief that the first result is best. Georges in 2014 had a study about comparing students' preferences for the library's federated search tool with Google, and found that even when they hadn't been introduced to features that a federated search tool might offer, students were willing to use them to include a Boolean string or add limits to their search, anything that they could do to help them refine or focus their search. And so this study encourages libraries to include some of those options in their search interfaces. So with all of that in mind, I looked at 8 collections that are relevant to environmental scientists. The first 5 here are library databases that I access through the UBC libraries, and the last 3 are U.S. government agencies that came up a lot in the literature as important sources for environmental scientists. For each of these, I looked at a number of things. I looked at what access model they're using, as well as how deep the indexing goes. Is it full text or just a bibliographic record, or somewhere in between with some abstract or other surrogate? I looked at the user interface, including the search screen and the results display, and between the two of those, I looked for all of these aspects that offer users more control over their search, or that automate part of that, helping them to refine. So faceted search whether there's an option to help them construct a Boolean string, whether the system provides guidance on a controlled vocabulary it uses to help them find related terms, whether it highlights query terms in the results so you can see the terms and context within the documents, and also whether the system provides any suggested searches. And then finally, I looked at some things that are important to environmental scientists, whether there's an easy option for the searcher to indicate that they want a data set, and whether it's easy for them to describe the location of the results that they want. So with the library databases, the Global Environmental Justice Collection is a film collection, and that one was interesting to see. It uses a Boolean model, but what it's indexing is just the text related to each film, so the MARC record as well as a summary and reviews of the film. I'm not going to read through all of these, but I did think that the Agricultural and Environmental Science collection was interesting to note. This is a ProQuest product, and it was interesting because it was the only one of all the systems that I looked at that included suggested searches, and it also included multiple thesauri to help users find related terms and broader and narrower terms. And it also offered the most options for users to have control over the document type, so they could specify that they were looking for statistics and data, and also both on the search screen and the results page, there were options, ways for them to specify the location that they were interested in. 3 of these 5 databases that I looked at used an extended Boolean model, so I want to talk briefly about that. This was first described in 1983 by Sultan, Fox, and Wu. The extended Boolean model includes iterative searching that allows it to build on the exact match features of the standard Boolean model, while also providing results ranked by relevance as with vector space. After completing an initial search for all matching results, this model then conducts another search within the results, applying term weights based on inverse document frequency. The second round weighted search produces a similarity measure between the query and the documents in the collection. For the user, this means they get to browse a ranked results list, which is not possible with the standard Boolean model in which all results are considered equally relevant. This model also allows users to search with natural language. So they have the option of just entering a keyword or phrase. So among the government digital libraries I looked at, I thought that the U.S. Geological Survey was doing really interesting things with their Map Explorer, which is still in development. Basically, they provide a way for you to look at results that match your query on a map, and you can zoom in and click around on the different results, and it's one way to address that need that users have to find information specific to a location, and it allows users to match a keyword with a location by searching that keyword and looking at the results on the map. However, it still doesn't solve this problem of disambiguating geographic names within the search engine. For collections focused on the environment, looking into how to solve some of these problems related to location is really important, as well as making it easier for users to specify format type if they're looking for data. With user interfaces, the government digital libraries are underutilizing the ability to highlight query terms in a document in the search results. Another area for improvement, especially given that this is an interdisciplinary field, would be to introduce more use of controlled vocabularies in some of these databases to help users find appropriate search terms. I think it's important, given the vast differences across the collections I reviewed, that students are introduced to some of these differences broadly and taught how to make different databases work for them. And to wrap up, here are my references. Thank you so much for listening.